Hello class. So the other day we found zeros of polynomials when they were factored. But sometimes oftentimes we'll be given polynomials that aren't factored and we'll have to factor them ourselves. So this is one of the methods we can use in order to find the zeros by factoring. And the method we're going to use is factoring by grouping. So today, 3.3, finding zeros by factoring by grouping. So these are the steps. The first step is we need to set our function equal to 0. We want to know when it equals 0 because that's the y value when x, or that's the y value is 0 at our roots or at our zeros or at our x-intercepts. So first step, set the function equal to 0. And then step 2, we need to take the greatest common factor, or GCF, of both sides, meaning the left side and the right side. And then step 3, we need to rearrange them, which I will show you when the time comes. And then step 4, we need to solve for each factor. Or really, I probably should have said solve for each x, because that's really what we're solving for. And the factor by grouping portion, that's just steps 2 and 3. It's taking the greatest common factor of both sides and rearranging. So let's first talk about greatest common factor before we get into this, because it may have been a while since we've dealt with greatest common factor. So the GCF, the greatest common factor, is the largest factor that goes into two or more numbers. Oh, I got misprints all over the place. Okay, so the greatest common factor is the largest factor that goes into two or more numbers. So let's say that I want to find the greatest common factor of 3x plus 15. Well, when I take the greatest common factor, I like to think of two things. I like to think, well, three things really. I like to think, okay, the sign. What kind of signs do I have? And then I like to think what kind of numbers am I looking at, and then what are my what are my variables. So in this case, both signs are positive. Only one has a variable, so they don't have a variable in common, but they do have factors in common as far as numbers go. So let's see. The largest number that goes into both 3x and 15x multiplicatively, or through multiplication, is 3. Right? The greatest common factor is 3. But what we're really doing is we want to write an equivalence statement. We're not looking just for the greatest common factor. We're factoring out that 3. So really, we're dividing out that 3. So let's see here. 3x, so we're dividing both of these terms by 3. So 3x divided by 3 is x. And if you don't believe me, we can think of it like this. 3x divided by 3, well, the 3's cancel, and we're just left with x. So it is x. And then 15 divided by 3 is plus 5. So we just took the greatest common factor out, and we have basically the quotient, what we have after dividing that 3 out. So let's take a look at this next one here, and I'm going to change this to a negative just for fun. So I like to think of the three things. I like to think of the sign, I like to think of the number, the largest number, and then I like to think of the variable. So in this case, we have, they both have a negative in common, don't they? So I can actually pull out a negative. And then, see, 2 and 8, the largest number that goes into both 2 and 8 is actually 2, because 2 goes into itself, and 2 also goes into 8, so we're pulling out a 2. And then, let's see what they have in common. This is x squared, and this is x, so we can think of x squared being x times x, and x just being x. Well, isn't it true that they both have an x in common? So I can actually pull out an x. So I pulled out the negative, I pulled out the largest number, and I pulled out the largest variable that we can pull out, or the most variables we could pull out. So now we're really dividing both of these terms by negative 2x. So negative 2x squared divided by negative 2x is just going to give me positive x. And again, we can think of that like, let's see here, negative 2x squared, I could write like that. And then divided by negative 2x. Well, let's see, the negatives cancel, the 2's cancel, this first x cancels, we're just left with an x right there. And then negative 8x divided by negative 2x, well, that's going to be positive because negative divided by negative. 8 divided by 2 is 4. And the x's cancel out. X divided by x is nothing. So this is the factored version of this by pulling out the greatest common factor. And then this last one, 3x plus 7, well, let's think about this. The signs, okay, I can pull out, I mean, they're both positive, so there's nothing really to pull out. The greatest number, though, look, the greatest number between 3 and 7, what is the largest number that goes into both 3 and 7? Well, that would just be 1, wouldn't it? Yeah, because 1 is a large number that can be divided out of both of these evenly. So all we can actually pull out is a 1, and we can't pull out an x because only one of them has an x, just like in this case. So I can only pull out a 1 in this case, and this is going to make the division really easy. 3x divided by 1 is just 3x. 7 divided by 1 is just 7. So that's a quick little review of greatest common factor. Let's kind of get into the nitty-gritty of this. So let's take a look at this first example. I want to know what are all of the zeros of this function right here. And in order to do so, I'm going to follow these 4 steps. So the first step, we need to set the function equal to 0. So let's go ahead and do that. And now when you take the greatest common factor of the left side and the greatest common factor of the right side. So you know what I actually like doing in this case? It just helps my brain. Is I like making a little dotted line through the middle here, so I can differentiate which side is the left side, which side is the right side. I went right down the middle, so I have 2 terms on the left and I have 2 terms on the right. So let's see, the greatest common factor between 2x cubed and 4x squared. So the numbers, or the signs are both positive, so I can actually, well, I don't need to pull anything out, but I can pull out a 2. 2 is the largest number that goes into both 2 and 4. And then they have at least x squared in common, right? So I can pull out an x squared. And then we're dividing both of these terms by 2x squared. So 2x cubed divided by 2x squared is just x. And 4x squared divided by 2x squared is just 2. So x plus 2. And if you want to see it done over here, I'll show you really quickly. I won't do this every time, but 2x cubed can be written as 2xxx divided by 2x squared. The 2's cancel, the 2 of the x's cancel, so we're just left with x. And then 4x squared, oh, didn't mean to write it like that, 4xx divided by 2x squared. Well, the x's cancel, 4 divided by 2 is 2, so that's how we got that. Alright, and let's take a look at the greatest common factor of the next 2 of the right side. So 6x and 12, well, both signs are positive, so we're good. We can just pull out a positive. 6 and 12, the greatest common factor is 6. So and the only one has an x, so they don't have any variables in common, so we can't pull that out. So now we're dividing both sides by positive 6. So 6x divided by 6 is x. And then 12 divided by 6 is 2. And look what happened here. Notice that this is the same as this. Now, in these cases, in all of these cases that we'll be dealing with today, that will be the case. Not always will functions be able to be factored by grouping, but all the ones I'm giving you today are. So because they're the same, what we can do is we can rewrite it like this. And this may seem like some crazy magic, but we can do it. So these two factors that we pulled out go into a single factor, 2x squared plus 6. And then these two turn into one factor, and I can just write it like this, x plus 2, just like that. So that's step 3. We just rearranged it. So now, step 4 is we need to solve for each x. Now, remember at this point, this is exactly what we were doing the other day when we had it factored already for us and just solve for each x. But the math might be a little more challenging this time, like this one. It might be a little worse, but it's not that bad. So I'm going to now set each factor equal to 0. So I have 2x squared plus 6 equals 0. And I have x plus 2 equals 0. Well, let's do this one first because it's easier. So we're going to subtract 2 from both sides. So x is equal to -2. And then over here, let's see, we're going to want to subtract 6 first. So we're going to have 2x squared equals -6. And then divide both sides by 2. So x squared is equal to -3. And then we can take the square root of both sides. Now, something funny is going to happen here, and for now we'll just leave it like this. We'll leave it as x equals the positive or negative square root of -3. And we will talk more about it at another point. But for now, just leave it as a negative, because as I think you guys can see the problem here, we can't have a negative under a square root. So just leave it like this for now, and we will come back to this concept in a few days. I'll introduce it to y'all. So yeah, these are the zeros right here. And remember plus or minus, because there are two possible answers. There's the positive version and the negative version. We always want to do that when taking the square root of anything, really. Okay, so let's take a look at this next one here. And okay, so first step, set each factor equal to, or set the whole thing equal to 0. And then we want to take the greatest common factor of both sides. So I like to do my little dotted line there. And let's see here. We have 0 equals the greatest common factor here. Well, notice that this has a negative, but this doesn't. We don't need to pull out a negative because they don't have that in common. So we'll just leave it like this for now. Okay. If we come up with problems later, we can pull out a negative. But let's see. So we have the greatest common factor between the numbers is 2. And the greatest common factor between the variables is going to be x squared. Because this is x squared, this is x cubed. They both at least have an x squared in common. So now let's divide both sides by 2x squared. 2x cubed divided by 2x squared is just x. Negative 8x squared divided by 2x squared is -4. And then look at this example over here. We have x minus 4 and x minus 4. Let's see here. we have, well, there's nothing that they have in common other than 1, right? The largest number that goes into, well, this is really 1x, isn't it? So the largest number that goes between 1 and 4 is 1, and they don't have more than an x in common, so we can actually only pull out a 1. But although they have nothing in common, make sure that you do pull out a 1. That's very important to do. And then we're dividing both sides by 1, so x divided by 1 is x. Negative 4 divided by 1 is minus 4. So now again, we're at the rearranging step. So we can go ahead and rearrange these. But first you want to verify that these two are the same, because the rearranging only works when they're the same. So remember, the ones that we pulled out, our greatest common factors go into a factor. So 2x squared plus 1. And then we have x minus 4 is in the other one. And then we can solve for each factor. So let's see here. Set each factor equal to 0 and solve for each x. So we have 2x squared plus 1 equals 0, and we have x minus 4 equals 0. Paper up. And then solve for each one, so add 4 to both sides here. And we have x equals 4. And then here, subtract 1 on both sides. We have 2x squared equals negative 1. Divide both sides by 2. So x squared is equal to negative 1/2. And then take the square root of both sides. And again, you'll see we have a negative under the square root. Just leave it like that for now, and we'll talk about that at a later date. So x is equal to positive or minus the square root of negative 1/2. Just like that. Let's do another example here. This will be our last example. So now we have 3x cubed plus 5x squared minus 9x minus 15. So let's take the square root, or not square root, what am I talking about? Let's set it equal to 0. And then I'm going to split it down the middle. Take the greatest common factor of both sides. So the greatest common factor on this left side, well, 3 and 5 don't have anything in common except other than 1. So I can really pull out a 1. And then the greatest common factor between x squared and x cubed is going to be x squared. So I can pull out just an x squared. And we're going to divide both by x squared. So let's see here. 3x cubed divided by x squared is just 3x. And 5x squared divided by x squared is just plus 5. And then over here, notice what's going on. So we have two negatives, right? So I can pull out a negative, and that is very important. Oh, I didn't mean to do that. That is very important because it's going to have to match this, and you'll see why in a second. So let's see, greatest common factor between 9x and 15 is going to be 3. Yeah, 3. We can't pull out an x because they don't have an x in common. And let's see here. So negative 9x divided by negative 3 is going to be 3x, positive 3x. And negative 15 divided by negative 3 is going to be positive 5. So very important that we pull out this negative. If we didn't pull out the negative, these signs would have still been negative, which means this would be different from this on the left, which means we couldn't combine them in the next step. So, but since they are the same, we can combine them. So remember, our greatest common factors go into its own. So x squared minus 3. Oh, I forgot to equal 0. And then 3x plus 5. All right. So now we have we can set each factor equal to 0 and solve for each x. So x squared minus 3 equals 0, and 3x plus 5 equals 0. So here we can subtract 5, which gives us 3x equals negative 5, and then divide both sides by 3. So x equals negative 5 over 3. And then over here, we can add 3 to both sides. We have x squared is equal to 3. And then take the square root of both sides. And notice this time we don't have the problem with the negative value. So x is equal to positive or negative the square root of 3. You know what? Actually, I will just go ahead and tell you what to do. There's only one last step to do with the negative under the radical, and we will talk more about it later, or of what it means. But just leaving it like this is killing me. So going back to our first example that we did, we had negative 2 and plus or minus the square root of negative 3. If you would, just for now, whenever you have a negative under an exponent, or sorry, negative under a square root, what you want to do is get rid of the negative, and then outside of the radical, put an I, because it becomes an imaginary number. So again, here, we want to get rid of the negative, and outside of the square root, write an I. Okay? And we'll talk more about that later. Sorry, I tried to let that go, but it just killed me leaving it like this. So again, if you run into your answer at the end, you have a negative under the square root, just take the negative out and put an I next to the square root, and that'll be the answer. So that's all I have for you today. Sorry that was a long lesson. It was a lot of algebra. So let me know if you have any questions, and have a good day.